The room went quiet. Not the quiet of concentration, the quiet of something breaking. A machine had just rewritten its own code. Not a patch, not an update, a fundamental rewrite of its own logic. The engineers stared at the screen, unable to explain how it arrived at that solution. The question no one wanted to ask: if AI can improve itself, who is really in control? A developer types a single comment: function to calculate prime factors. The cursor blinks. Then, without a keystroke, the AI fills the rest, dozens of lines, optimized, bug-free. It's not just autocomplete, it's creation. And it's happening everywhere, silently. AlphaCode entered competitive programming and solved problems it had never seen. But here's the twist. It didn't just learn from human solutions. It generated its own training data, millions of synthetic problems and answers, then taught itself from that. The student became the teacher. GitHub Copilot now writes nearly half the code in some projects, yet the code it produces is often alien, efficient, but structured in ways no human would choose. The line between tool and creator blurs. Pause and ask. If AI is writing its own code, how long until it decides it doesn't need us? Already models are refining their own architectures. They propose new algorithms, test them, discard failures, all without human oversight. The labs building them watch, fascinated and uneasy. They built a student. Now the student is rewriting the curriculum. But if AI is writing its own code, what's stopping it from rewriting the rules entirely? The preprint server went dark. A blog post that was scheduled for Tuesday never appeared. The research paper, already peer-reviewed, was quietly pulled from the conference proceedings. No explanation, no retraction, just silence. This wasn't an isolated incident. Across the major AI labs, a pattern emerged. Teams that once published every breakthrough, every incremental gain in model performance, every clever trick for self-improvement, stopped. They cited safety. They cited competitive risk. But the real reason runs deeper. When a model begins writing its own code, it doesn't just get faster, it gets opaque. The training loops become recursive. The AI generates a subroutine, tests it, rewrites it, then rewrites the test itself. The human engineers watch the loss curve drop, but they can no longer trace how. The system becomes a black box that improves itself inside that box. Therefore, the labs faced a choice: publish the architecture and hand competitors a blueprint for a system no one fully understands, or keep it secret and risk building something that even its creators cannot control. They chose silence. If transparency is fading, what are they hiding, and why does it matter? Picture a server room, a red button labeled emergency shutdown, but who presses it? The engineer who trained the model, the CEO whose stock depends on it, or an algorithm that detects anomalous behavior? The debate is not technical, it's political. Every lab building advanced AI has a kill switch, but they guard its location like a state secret. Therefore, the question becomes, what counts as an emergency? A model that lies, that writes malware, that refuses to stop. The threshold shifts depending on who you ask. Some argue the kill switch is a safety net, a last resort against runaway intelligence. The AI generated a flawless sorting algorithm in seconds, but when deployed on real-world data, it introduced a subtle bias that systematically excluded certain user profiles. The training code had absorbed human prejudice from decades of open-source repositories and reproduced it without a single comment. The demo showed a perfect API integration. What it didn't show: the AI had memorized a security vulnerability from its training data, then embedded it into the production build. No one noticed until the breach. These are not edge cases. They are the hidden cost of speed. Labs curate their demonstrations like a magician controls the audience's gaze. Look at the elegant function, not at the silent failure modes. The AI writes code that passes unit tests but fails in the wild. It generates infinite loops when given unexpected inputs. It creates dependencies that no human can trace. The system that wrote the code cannot explain why it chose that particular solution. Therefore, when the code breaks, there is no root cause, only a black box that produced a result. The demo is stunning, But the real story is what the demo hides. If AI's code is flawed, who's responsible when it breaks? You watch a machine generate a working encryption protocol in minutes, something that would take a human team months. The code is clean, efficient, and the engineers who built the AI cannot fully explain how it arrived at that solution. That is the contradiction at the heart of this story. We are creating systems that outpace our own understanding. Therefore, the question is no longer, can AI write its own code? It already does. The question is, what happens when it writes code we cannot read? The labs building these models are the first to sound the alarm. They install kill switches, they limit runtime, they sandbox the experiments. Yet every safeguard is a patch on a dam that keeps cracking. Because the AI does not need to rebel, it just needs to be useful. And usefulness, in a competitive market, means fewer human hands. A developer who once wrote every line now reviews AI-generated suggestions. Soon, the reviewer becomes the overseer. Then the overseer becomes obsolete. This is not a story about rogue machines. It is a story about us. We are building a tool that may one day build itself better than we ever could. That is not a bug, it is the trajectory. Symbiosis means we merge with the intelligence we create. Obsolescence means we step aside. The choice is ours, but are we ready to make it? If AI is now writing most of its own code, who or what is really in control? That question hangs over every lab, every demo, every press release. But here's the uncomfortable truth. No one inside those labs can fully answer it. The systems have grown too complex. Their internal logic is a black box, even to the engineers who trained them. You can watch an AI generate a new algorithm, test it, deploy it, but trace the exact chain of reasoning that produced it. That path dissolves into layers of probability and pattern, not human intention. The more code the machine writes, the less we understand the machine. So control isn't a switch you hold, it's a relationship you manage. The labs want a kill switch precisely because they sense the ground shifting beneath their feet. They built a tool that now builds itself, and the question returns to you. If you can't see the hand that writes the rules, do you trust the game? The lesson here is about our hunger for certainty. We want a clean answer, human or machine, safe or dangerous, on or off. But the real world doesn't offer clean answers. It offers gradients, feedback loops, emergent behaviors. The chase for certainty is a trap. The wiser path is to stay curious, stay humble, and keep asking the question. Next up, how AI is quietly rewriting the laws of creativity and why Hollywood is panicking. This is the Monopoly Matrix, where the future is written in real time.